Okay, so for today we're going to have a look at function notation. So if we look at the gx equals 4x plus 1, which is here, then we know that that looks like a linear function, so it's a straight line, and we're mapping x onto y, and the function is 4x plus 1. So it goes through 1 on the y-axis and it has a gradient of 4. So the graph looks something like that. Now, another way of saying that might be that y is equal to 4x plus 1. So this is the same as writing this function. They both mean exactly the same thing. On one of them, we're saying that g is a function of x, which is equal to 4x plus 1. And on the second, we're saying that y, a new variable, is equal to 4x plus 1, which is how we can then map it as a graph. Another way that you might see this is g, and it's where x becomes 4x plus 1. And what this is saying is the function g transforms every x value into the value 4x plus 1. So each of these x values become, instead of x, but 4x plus 1, which is what gives us the y value on the function. So all of these things mean exactly the same. So if we look at the f of x function, we could write that as y equals x squared plus 2x. And we could also write it as the function f is where x becomes, it's a bit too long there, where x becomes x squared plus 2x. They all mean exactly the same thing. So moving on to the notation, g of 2, all we've done here is we've replaced the x value with a 2. So all we're saying is that x equals 2. So we take our g of x function and we replace x as 2. So I've now got 4 lots of 2 plus 1, which gives me 8 plus 1, which gives me 9. So g of 2 is equal to 9. And we're doing exactly the same with f of 3. We're just saying that x is now equal to 3. We've replaced this x and it's now become 3. So that gives me 3 squared, and I'm being careful to write my brackets in, plus 2 times 3. So 3 squared is 9, plus 2 times 3 is 6, and that gives me 15. So this function is equal to 15. And then we can go slightly harder. So I've still got the same f of x and g of x functions. So it's exactly the same. And I'm now going to look at g of a and f of x equals 0. So the first one looks different, but it's exactly the same. So this time x is equal to a. So on there, all we need to do is replace the a instead of the x into the g of x function. So I have 4 of a plus 1, and I simplify that as far as I can. I can't do anything else, so my answer is just 4a plus 1. Now in this one, I'm setting my equation equal to 0. So I'm actually taking my f of x function and writing it underneath the f of x, and that is equal to 0. And now I can try to solve my equation. Now because it's a quadratic and it's equal to 0, I can take out x as a factor and have x plus 2 in my brackets. So if I were to multiply this out, that would give me the same as x squared plus 2x. And here I've got two different things that are equal to 0. So either the x is equal to 0 or the x plus 2 is equal to 0. Because the only way to multiply two numbers together, this is a little multiply, and to make 0 is to have one of the numbers as 0. So either x equals 0 or x equals minus 2. So I've subtracted 2 from both sides. So that has two solutions. Now this is the first one where we've found x, and that's because it's an equation. We've got an equal sign in the question. Okay, so the next question is quite similar to the one we were just doing. So it's g of x is equal to 37. Now g of x was equal to 4x plus 1. So I can repeat that under g of x. It's a different way of writing g of x. And that is equal to 37. And from here, I'm then solving it to try and find what x is equal to. So first of all, I could subtract 1 from both sides. And then that would give me 4x is equal to 36. And then from there, I can divide by 4 from both sides, and then that gives me x, which is equal to 36 divided by 4, which is 9. The second question then is f of x equals g of x, and what we're doing there is actually placing together the g of x and the f of x, or more useful, x squared plus 2x and 4x plus 1. So f of x is equal to x squared plus 2x equals g of x, which is 4x plus 1. And then from here, we're trying to solve the equation. Now, as you can see from the squared here, it is a quadratic equation. So to solve a quadratic equation, you need to try and make it equal to 0 first. So I'm going to move everything onto the left-hand side of that equation to keep the x squared term positive, to keep this one positive. So first of all, I could subtract 4x from both sides. So I'm lining that up with the column with the x's in it. And that gives me x squared plus 2x minus 4x. So that gives me minus 2x equals 1. Then I can subtract 1 from both sides. And now I've managed to get the equation equal to 0. So I've got x squared minus 2x minus 1, which is equal to 0. And then from here, you're trying to decide if there's any numbers that add together to make minus 2 and can times together to make minus 1. Now, the only numbers that times to make minus 1 are 1 and minus 1. So they're not going to add to make minus 2x. So that means that we're going to use our GDC. And you can go straight to using your GDC here if you wanted to. So on our GDC, we can go to Menu, followed by Algebra, followed by Polynomial Solver. And on the Polynomial Solver, you'll be asked to pick a degree. And the degree is just asking for the highest power. So for us, it's 2. So we write that it is degree 2. And then you type in the coefficients of x squared, which is 1, of x, which is minus 2, and then of the numbers, or the integer value, which is minus 1. And from there, you will then get your solution.